Okay, for example 3, we're trying to find the horizontal and vertical asymptotes of our function x squared plus 2 over x squared plus 1. So as you might be seeing, we're kind of developing a new way to find these horizontal and vertical asymptotes by using limits. So for horizontal asymptotes, we're going to take the limit, as x approaches infinity, and we know that's going to be equal to the limit as x approaches a negative infinity. So for horizontal asymptotes, they're going to be the same. And how can we figure out what that's going to be? Well, we can take our function and look at the numerator and find the highest degree term. The highest degree term in the numerator would be x squared. And we want to divide that by the largest degree term in the denominator. And why does that work out? Well, as we're getting larger and larger values, either negative infinity, approaching negative infinity, or positive infinity, is the plus 2 and plus 1 really making a big difference in the values? Say if we plugged in 10 million in for x, the plus 2 is not going to change the values of our function very much. So the biggest impact we're having is with the x squared and the x squared, so that's really what our limit going to affect the limits here. And we can simplify x squared over x squared to what? Those would cancel out, so we're just left with 1. So the limit as x approaches infinity and the limit as x approaches negative infinity of x tends toward 1. So that gives us which asymptote? The horizontal asymptote. Now let's take a look at vertical asymptote. So again, it's going to be where our denominator is equal to 0. So we can just set x squared plus 1 equal to 0 and solve for x. But there's no real values where x equals the square root of negative 1. So we have no vertical asymptotes for this function.